Hey guys, welcome to this video on integration by parts. At this point, you should know how to integrate basic functions, including some polynomials and other problems that can be solved with u-substitution. However, not all functions fall into these categories, and today we will discuss another method of integration that will enable us to solve more integration problems. This method is called integration by parts. To begin, let's take a look at a problem we should already be able to solve. The integral of x plus sine of 2x dx. First, we can break this into two separate integrals by using the addition rule. So the addition rule says that we can break it up where there's a plus sign, so we'll have the integral of x dx plus the integral of sine 2x dx. The first integral, x dx, is simple to solve. Just increase the power by 1 and divide by the new exponent. So this part is equal to, if you increase x to the first power by 1, you'll get x squared, and then divide by 2 is the same as multiplying by 1/2, plus c, our integration constant. For the second integral, notice that the derivative of 2x is 2, which is a scalar multiple of the implied 1 in front of the sine function. Because of this relationship, we can apply u-substitution to solve the second integral. The integral of sine 2x becomes the integral of 1/2 sine of u. So if we have the integral of sine 2x dx, and we call 2x our u, then du is equal to 2 dx. So this will be equal to the integral of sine of u times du, but we're actually going to have to do 1/2 du to get it to be equal to dx. We just divided by 2 on both sides. And since we have a dx here, that's what we're going to want to do. So we're going to write 1/2 right here. Now we integrate this, and we'll get negative 1/2 cosine of u plus c, because negative cosine is the integral of sine of u. Now all we have to do is plug in our u, which is 2x, and we get negative 1/2 cosine of 2x plus c. Now all we have to do is put our addition terms back together. So this is equal to our first part, 1/2 x squared. We're going to leave the c alone for a second, and then minus 1/2 cosine of 2x plus c. Don't be concerned by the fact that one of our c's went away. When we add together our two integration constants from the first and second terms, they combine to form another constant, so we are safe to lump them together using just one letter. Solving that problem wasn't so bad, but consider this next problem. The integral of x times the sine of 2x dx. The integral of x sine of 2x is almost identical to the one we just solved, except now we're dealing with multiplication, where before we were simply adding the two terms. Unfortunately, we can't just break this integral into two separate integrals like we can with the addition rule. What can we do then? Think back to what we know about taking derivatives of products. We had a special rule, the product rule, to help us with those types of problems. Similarly, with integration, we have a defined process for handling products, and it was actually derived by mathematicians from the product rule for derivatives. This process, as you might have guessed, is called integration by parts, and it goes like this. If you have an integral that can be written in the form the integral of u dv, then its solution is equal to u times v minus the integral of v du. At first glance, this may seem a bit confusing or unhelpful, but let's break it down and then apply it to our example. To begin, there are two functions, u and dv, whose product we are interested in taking the integral of. If we know how to take the integral of dv and we know how to take the derivative of u, then we can use a little bit of algebra to apply the integration by parts formula and determine our answer. Consider again our example. The two functions here are x and sine 2x dx. So we will assign them to be our u and dv respectively. So our u is x, and our dv is sine 2x dx. Now notice that I kept the dx with the dv. This is important because we're going to integrate this part later on. In order to determine our solution using the integration by parts formula, we need to calculate u times v and the integral of v du. We know that u equals x, but what is v? To find v, we just need to take the antiderivative of dv. So v is equal to the integral of sine of 2x dx. Now remember, we found this earlier, so this was equal to negative 1/2 cosine of 2x. And we're not going to write the plus c yet because we'll do that at the end. Since we're integrating a whole indefinite integral, we'll do that at the very end. We don't have to worry about it in our little steps in between. So now we can calculate u times v. uv is equal to x times negative 1/2 cosine of 2x, which is equal to negative 1/2 x cosine of 2x. To find the last piece, the integral of v du, we need to compute du and then integrate. The derivative of u is the derivative of x, which is 1. So du is equal to dx. Putting this together, the integral of v du is equal to the integral of negative 1/2 cosine of 2x dx, because that's our du part. Let's put together what we have so far. Remember, the formula tells us that the integral of u dv is equal to u times v minus the integral of v du. We assigned u to equal x and dv to equal sine of 2x dx, which then made du equal to dx and v equal to negative 1/2 cosine of 2x. Putting these pieces together now into the formula, we have that the integral of u dv is equal to u times v was negative 1/2 x cosine of 2x minus the integral of v du. So minus the integral of negative 1/2 cosine of 2x dx. All we need to do from here is compute the second integral and simplify the entire expression. Let's move that negative 1/2 outside of the integral, which will cancel out the negative sign. So this first part's going to stay the same, negative 1/2 x cosine of 2x. And we can pull this negative 1/2 out, so we'll have minus a negative, which becomes plus 1/2 times the integral of cosine of 2x dx. Now the antiderivative of cosine is sine, and we pull out a 1/2 because of this 2x in here. So that'll look like this. Again, this first part stays the same, negative 1/2 x times cosine of 2x plus 1/2 times the integral of cosine of 2x, which is 1/2 sine of 2x. And this is where we're going to add our plus c, because we're at the very end and we just need to simplify. So now, all we have to do is simplify, and we do that by, again, keeping this first part the same, negative 1/2 x cosine of 2x. There's nothing we can simplify in this part. And then multiplying 1/2 times 1/2 is 1/4. So plus 1/4 sine of 2x plus c. So our final answer is negative 1/2 x times the cosine of 2x plus 1/4 times the sine of 2x plus c. This process may seem long, but with practice it will come along without much difficulty. At the beginning of this problem, we decided to let u equal x and to let dv equal sine of 2x dx. This enabled us to solve the integral using the integration by parts formula. However, if we would have tried to solve the integral with these switched, that is u equal to sine of 2x and dv equal to x dx, we would have run into some problems. The new integral, the integral of v du, would have been x squared cosine of 2x dx. Like the problem we started with, we cannot easily solve this new integral with previous methods. By choosing incorrectly, we effectively go in circles. Clearly, it is important to choose correctly which functions will be u and which will be dv when we integrate by parts. But how can we know the correct choice apart from trial and error? Some mathematicians have developed a method for making this choice called ILATE. ILATE is an acronym that helps us choose our u based on an order of priority. When approaching a problem for which you will need to use integration by parts, first check to see if there is any I, inverse trig function. If so, select this to be u. If not, then look for an L, logarithmic function. If there is one, then it will be what you choose for u. Otherwise, check for an A, algebraic expression, such as x or x squared. If there is none, see if there is any T, trigonometric functions, like sin x or cosine x. If none of the previous expressions are in the problem, then finally check for E, exponential functions, such as e to the x. Whichever of these you find in order of ILATE, that will be your u. The part of the integral that is not chosen to be u will be your dv. Let's look back to our problem from earlier one more time to apply ILATE. The integral of x sine of 2x dx. First, are there any I, inverse trig functions? No, there are not. Next is L. Are there any log functions present? Again, no. Are there any A, algebraic expressions? Yes. By using ILATE, we see that x is the best choice for our u, because it is an algebraic expression. Notice that the sine function is a t, trig function, but we don't choose that to be u because the t comes after a in ILATE. Let's work one more problem. The integral of x squared times the ln of x dx. We can't use simple antiderivatives or u-substitution to solve this integral. And because we have a product of two functions, x squared and ln x, we're going to use integration by parts. Which of the two will be our u and which will be our dv? We will use ILATE to decide. There are no I, inverse trig functions. There is, however, an L, log function. We assign u to equal ln x. And we have no need to continue with a, t, and e. The leftover portion of this integral, x squared dx, is our dv. To use the integration by parts formula, let's go ahead and determine what du and v are based on our choice. So du is the derivative of ln of x, which is 1 over x dx, and v is equal to the integral of x squared dx, which is equal to 1/3 x cubed. Remember, we don't have to put the plus c yet, we'll put that at the very end. Because the formula for integration by parts is the integral of u dv is equal to u times v minus the integral of v du. We plug in our substitutions and get this. So u times v is ln x times 1/3 x cubed. So I'm going to write the 1/3 x cubed in front. That's just the more formal way to write it. And then minus the integral of v du. So the integral of 1/3 x cubed times du, which is 1 over x dx. Now we're going to go ahead and simplify. So this is equal to 1/3 x cubed ln of x minus the integral of 1/3, and then x cubed times 1 over x is equal to x squared. So this will be x squared dx. The next step is that we'll pull out our 1/3. So again, this part stays the same. We can subtract 1/3 integral of x squared dx. And then we can integrate x squared. To get 1/3 x cubed. And this is where we'll add our plus c. Now all we have to do is simplify this part right here. So we have 1/3 x cubed ln of x minus 1/9 x cubed plus c. And that's our final answer. Let's briefly run back through everything we've talked about. First, not all integrals can be solved using basic antiderivatives and u-substitution. Integration by parts allows us to work out more integrals, specifically those containing products of functions, using the formula the integral of u dv is equal to u times v minus the integral of v du. To make the best choice for which function should be u, we use the acronym ILATE. Inverse trig functions, log functions, algebraic expressions, trig functions, and finally exponential functions. The part of the original integrand that we do not select to be u will be dv. Before plugging everything into the formula, we need to calculate du, the derivative of u, and v, the antiderivative of dv. Once we have all four of those pieces, we simply substitute them all into the formula and simplify. With a little practice, you'll be fluent with integration by parts in no time. Thanks for watching and happy studying.